All right. Hey, Christina and Romario. How are you guys doing today?
Yeah,
Good. Good. That's good to
I'm
hear.
doing fine. How are you?
I'm good. I'm good. It's good to see you guys again. It's pretty nice.
Christina
So,
Lamar. How are you guys
yeah.
doing today?
I didn't hear what I said.
No, no,
Oh, you're kind of breaking up, so I'm not hearing you. Not hearing everything I says today. But yeah, let's see what we can do for today. So we're gonna focus on algebra today. And hello to everybody, to the persons who are live on YouTube. It's good to see you guys as well. So we have like another 30 seconds or so. Let me just finish up something and then I'll be right there. All right? Give me 1 minute. All right. So let's see if we can get started. So what we want to do today, we're focusing on algebra, and our aim is that by the end of the session, we want to kind of look at how some algebra questions look in this exam and then see how we can do them, see some tips and tricks. And I tried to pull a lot of different questions from different areas. But I know for the most part, most people you've seen algebra already. You kind of have an idea of what is involved. Probably just might not remember exactly how to tackle them or what to do. So we're gonna focus mainly on that for today's session. All right. So let me again, for those on YouTube, if you want to come in and ask questions, the link is there for the Zoom, so you can come and ask if anything. But if you're on YouTube, you can type in the chat. That's fine too. So let's get started. So first, let's kind of remind ourselves of some of the stuff that we know about algebra. So let's start with stuff like we know we have like and unlike terms. You know, what else do we know? We know we have stuff like equations. We know we're talking about stuff like inequalities. Am I missing out anything?
Factorization.
Yeah, that's good. Factorization, that's one. What else? What else am I probably missing out? How about simultaneous equations? That's something else. So we got that as well. I don't think I'm missing out anything else. I might be. If I am, just remind me still. But I don't think I'm missing out. I hope I'm not. Oh, linear equations. Yeah. So I'd put that here. And that also jogs my memory for algebraic fractions. So we know these are some of the stuff that we're talking about when we're dealing with algebra. So in any problem that you have though, any algebra problem and anything at all, any topic for that matter, I don't know if you guys have watched the video that I uploaded on how to solve problems, because that's the basic blueprint for any problem that you need to solve. You have to follow those 4 steps. So if you don't watch it yet, you can check out that video. But you're basically asking yourself, what do I want to know? What do I already know? Uh, what's my plan? And then how do I know if I'm right? Yeah. So those are the 4 questions that you have to keep in mind to solve any problem at all. And that applies too for algebra, because a lot of the stuff in algebra are going to be problem solving questions. So we're going to, while we work, I want you to think about those steps in the things that we're going to do. Right? So let's just get straight to it. Let's start here. So here is a CSEC question. To be honest, you know, I don't remember what year this question was, but I know it was there. Believe me, it was there. And you're going to be doing a little something to find, for example, the size of some stuff and some simultaneous equations. So that's where we want to start. Right? No, I think I didn't remember to ask in the chat if anybody feels, if anybody has any difficulties. Remember, we're here. I'm here to help you. I'm not leaving anybody behind. So if you have a question, you can ask in the chat, or if you're not clear on something, you can say it so that I can help you. Zin? All right, let's get to it. So the first one is, given that A star B is equal to AB minus B divided by A, evaluate 4 star 8 and then 2 star 4 star 8. I wonder if you guys know what topic this is, what area this is. We didn't write it in our cloud, but I wonder if you guys have seen it before. I wonder if you guys see this thing before. Are we not so sure what it is? Give everybody a chance to think about it. Yeah, I'm looking out on it. Oh, I'm seeing what you're saying, Sean. Yeah, I'm gonna try and post that in the chat. Hold on one minute, let me try to do that. Put the code in here. Oops, cannot carry everything. Yeah, sorry guys, just give me a minute. Let me just send this in the chat. I was gonna do it before I signed in and I didn't. So it's kind of proving a little difficult. All right, yes sir. I'm gonna just put the meeting ID in the chat. And you can just go to Zoom, type in this ID, and you will get here. It's the same ID going forward. So any other sessions that we have, that's the ID that we're going to use. All right, yeah, I'm just getting a chance to check the chat. That's right, binary operations. Good, yeah. So that these are binary operations. And in binary operations, it's kind of like substitution, where we're just going to replace our values or letters or our symbols with the numbers that are there. So if this is A star B, then 4 star 8 would mean that now A is 4, right? And B is 8. So anywhere we say A, we're going to put 4. And anywhere we say B, we're going to put 8. So that's going to be 4 times 8 minus B, which is 8, divided by A, which is 4. All right? So now 4 times 8, that is 32. And then 8 divided by 4 is just 2. So that's 32 minus 2, which is equal to 30. Right? So A, put it on mute. A star, sorry, 4 star 8 would be equal to 30. So that's what we think about in binary operations. We just replace those symbols with the numbers that we're given. Right? Everybody good so far? All right. Okay, great, good. Now let's do 2 star 4 star 8. What does that mean? This one, it might look a little bit more complicated, but all it's really, you see, because we have the brackets here, it's telling us that you do 4 star 8 first. But we already know what 4 star 8 is. 4 star 8 is 30. So that means this is just really saying 2 star 30, because we know that this is 30. All right? So 2 star 30, we're using the same operation, the same binary operation. So it's going to be A times B, so that's 2 times 30 minus B over A. So that's 30 divided by 2. All right? Now, 2 times 30 is 60, and 30 divided by 2 is 15, and 60 minus 15 is 45. So 2 star 4 star 8 is equal to 45. And that would be our answer. You would get, I think I can say confidently, you would get 1 mark for substituting the values correctly, and then 1 mark for computing it correctly. So a mark for figuring it out. Right? So are we, everybody good with that one? Anybody has any questions, or that's okay? Or are you thinking the same thing? The first one, all right, let's look back on the first one. So what we're saying is that this is a binary operation. This thing here, so we call a binary operation. And it's just another way to represent an operator in math. So, you know, like we have plus and minus, and that tells you what to do. In the same way, these are some more complicated looking operators, but essentially they're doing the same thing. So when you say A star B equal AB minus B divided by A, it just means that whatever A is and whatever B is, you're just going to substitute the 4 and the 8. So it's really just substitution, you know. It's really just substitution. So anywhere you see A, now you're going to put 4. Anywhere you see B, now you're going to put 8. That makes sense, Sean? A little clearer? Oh, I'm not hearing you. Oh, you go to the chat. Let me see what you said. Okay, good. So that means now, since A star B is AB minus B divided by A, I see an A, I'll put 4. I see a B, I'll put 8. I see a B, I'm going to put 8. And I see a A, so I'm going to put 4. So that's why it's 4 times 8 minus 8 divided by 4. All right? So that's how we got that. That's how we were, and then we just work that out. So 4 times 8 is 32. 8 divided by 4 is 2. And we're good from there. So let's see if, oh, let me see what she's saying. That's good. All right, great. Good vibes. Let's look at the next question. It says simplify. This should be expressing. Who wrote expression here? Simplify expressing your answer in its simplest form. 5p divided by 5p over 3q divided by 4p squared over q. Right? Let me make that division sign crystal. Now, what are we going to do here? How are we going to solve it? Well, we want to divide 5p over 3q by 4p squared over q. You know, when we're dividing fractions, it's the same thing as writing the first, changing the sign, and flipping the second. So it's going to be q over 4p squared, right? Or finding the reciprocal of the second term. And then now we can go ahead and try to simplify. So here we have P, and here we have P squared down here. So we see where we can cancel out, because P into P goes one time, so that gone, and then P into P squared is going to be P. Likewise, we have a Q here. Q into Q is 1, and Q into Q is also 1, so those cancel. So our answer is going to be 5 times 1, which is 5, divided by 3 times 4p. Yeah? 3 times 4p, and 3 times 4p is 12p. So that's why our answer is 5 divided by 12p. Yeah, that's the word I'm looking for, Christina. Reciprocal. Yeah, that is it. Yeah. So that's how we could have simplified our expression there. If that one's clear with you guys, if that's clear, everybody put a thumbs up in the chat for me so I know you're good. And if it's not so clear, you can put your N or your thumbs down. Let's see if we can fix that. Good, everybody good? All right, good vibes. So those are some other types of algebraic questions that you might see. Now let's go down to some simultaneous equations. I don't know, some of us probably we haven't seen this in a while. In the chat, I want you guys to rate yourself for me. Where would you put yourself with simultaneous equations? Would you give yourself a 10 out of 10? Would you give yourself a 1 out of 10, an 8 out of 10? How you feel about simultaneous equations? Let's see what you're thinking. All right. Everybody's saying they're not fully there. They're kind of like halfway there. They're not 100% there, the 5s and the 6s. And that's all right. That's all right. So let's see. The main thing that you have to remember when we're talking about simultaneous equations, when we're eliminating, that is when we're trying to get rid of one variable, we're just aiming to get at least one set of variables to be the same thing. That's what you want to focus on. So because we have two variables, we can't solve the two of them at the same time. So we have to try to get rid of one. So once you remember that, then you should look out for that whenever you're solving. And we're going to do that in this question. So it says a stadium has two sections, A and B. Tickets for section A cost $8 each, and tickets for section B cost $B each. Johanna paid $105 for 5 section A tickets and 3 section B tickets. Rhea paid $63 for 4 section A tickets and 1 section B ticket. First, we want to write two equations in A and B to represent the information above. So what do we know? Let's start with Joanna. Joanna paid $105 for 5, let me highlight that, 5 section A tickets and 3 section B tickets. So even if we don't know how much a section A and B ticket costs, we know that 5 of them, right? Because we know they cost $8, so we know 5 times A plus 3 times B is going to be equal to 105. In other words, 5 section A tickets and 3 section B tickets is going to be $105. Right? So that's an equation that we could come up with from what Joanna had. Could you come up with an equation for what Rhea had? Could you come up with her equation? Put it in the chat, let me see. So what can you say about Rhea? Let me see what you're thinking. So look at what it says for Rhea. She paid $63 for 4 section A tickets and 1 section B ticket. how could we write that as an equation? Looking out in the chat to see what you guys are thinking. So let me see. Remember, even if you're not sure if you're right, still write it in the chat, because that can give me an idea. Say, oh, probably we need to focus on this, or we need to focus on that. So still write it in the chat, even if you think you're not there. All right. I see two people. What you're thinking. And yeah, both of you guys are thinking the same thing. And that's right. Yeah, that's right. Akeem and Christina. So it would be 4a. Oops. Sorry. 4a plus b is equal to $63. I should really write the dollar signs here. Because what are we saying? Rhea paid $63 for 4 section A tickets. So 4 section A would be 4A, and so let's write it out. So 4A, 4 section A tickets, and in other words, plus 1 section B ticket. So that's 1B or just B. So 4A plus B. What about 4A plus B? Rhea paid $63 for them, so it must be equal to 63. Right? So it would be 4a plus b equals 63. And now let's call this one equation 1. And let's call this one equation 2. Right? Anybody's not sure how we got those? We're good to go? We match up those equations. Just want to make sure. All right, so look, follow me now, right? John, so look now. So we have 4A, because it says 4 section A tickets. In other words, you can think about it like this. What if a section A ticket costed or costs $10? Right? Then if you get 4 of them, it's gonna be 4 times 10. What if it was 15? Then we know it would be 4 times 15. But because we don't know, we just know it's A, that's why we say 4 times A. Because whatever A is, 4 section A tickets will be 4 times that. Right? Likewise, a section B ticket is just gonna cost B. So if it's $10, it's just $10. Boom. If it's $20, it's just $20. Done with. Yeah. So 4A and B plus the B is equal to 63. Why equal to 63? Because it says Rhea paid $63 for those. Okay. So altogether, she paid $63 for that. So that's how we got the 4A plus B equals 63. Yeah. All right. Now we want to calculate the values of A and B, and we already have those equations here. So remember I was saying, when you're doing simultaneous equations, you just want to get one set of the variables to be the same thing. So I could either try it with A or I could try it with B. I'm going to do it with B because up here I have 3B and down here I just have B. So what could I do to get those two to be the same? I could multiply this by 3. I could multiply the B here by 3. But the thing is, if I multiply that by 3, remember in an equation, what I do to one thing, I have to do to everything. So I'm going to have to multiply the whole equation by 3. Okay? So we can get the two of them to be the same by multiplying equation 2 by 3. I just want them to be the same. Once I get them to be the same, we're good to go. So let me write back equation 1. 5a plus 3b equals 105. And then now remember I'm multiplying all of equation 2 by 3. So that's going to be, let me write it here. That's going to be 4a times 3. And what's 4a times 3? That's 12a. What's 3 times b? Of course, that's 3b. And what's 3 times 63? It's 3 times 63. So if we do that, do the maths with that. 3 60s is 180, 3 3s is 9, so that's going to be 189. Now, b, the terms for b are the same. And I can eliminate them because they are the same, right? So if I do that, I can subtract this equation from the one above. So now that's going to be, what's that now? 5a minus 12a. What's 5a minus 12a, people? Write that in the chat for me. What's that? What's 5a minus 12a? I know I was going to say 7a though, but remember, be careful. Be careful with what you write. Because it's negative 7a, right? Because you have to be careful with your signs. If you're kind of messing with the signs, think about it in terms of money. You have $5 and you owe $12. What would your bank balance say? Would I say you owe $7? You still owe money. You owe more than you have. So it's negative 7a. Good? Yeah? And what is 3b minus 3b? 0. Poof, it's gone. So that's why we do that. We just get rid of it now. So once that gone out of the picture, we only have a on one side. And then over here, we're going to have 105 minus 189. What's 105 minus 189? What is that? What's that one now? $105 minus 189. What you guys get? I get negative 84. I wonder if you guys get the same thing. Yeah. So if negative 7a is negative 84, sorry, that means a is going to be negative 84 divided by negative 7. Because if it's 7 times a, then when we're going to do the opposite operation, it's negative 84 divided by negative 7, which is equal to positive 12. Because remember, negative divided by negative is positive. So a would be equal to 12. In other words, section A ticket costs $12. So we found that. Right? Now, what about the value of b? What is b going to be equal to? Now that we have a, we can solve for b. So we can choose any equation. I'm going to choose equation 2 because that was the easiest looking one. So using equation 2, equation 2. So using equation 2 to solve for b. Remember, equation 2 was 4a plus b equals 63. So now that is going to be 4. Let me write it. 4 times 12 plus b equals 63. And now we can solve for b. Yeah? Because if that is equal to 63, 4 12s, that's 48. And if 48 plus b is equal to 63, that means b must be equal to 63 minus 48. Yeah? And what is 63 minus 48? I'm seeing 15. And yeah, that's right. That's 48 plus 15 is 63. So therefore, B is equal to $15. Remember, we're working with the cost. Okay? So what have we figured out now? We can say therefore, put that in right. Therefore, a section A ticket. I always want to write out what you've done when you finish. A section A ticket costs $12 and a section B ticket costs $15. And you want to write out the thing, because you want when they're marking it in CXC, they say, wow, this girl knows what she's talking about. So you want to make everything cohesive. I usually don't like when you have the answer and you just leave it. I think you should kind of just make sure that you tie up everything, like you conclude. You know what I mean? You make it look nice, you can't make it just dry so. Yeah. So you can put it together. So those will be the values of A and B. If we're good with what we just did, again, let me see a thumbs up, and if you're not so clear, tell me from where. Are we all good? All right, Christina says she's good, all right. Yeah. All right, good, yeah. Good vibes. So remember, guys, the main thing I want you to keep in mind, simultaneous equations, just try to get rid of one of the variables. That's all you're doing. When you think about it like that, you're good to go. Now, let us look at this question. This was a question from the January 2016 paper. I think it was question 2. I think some of these had labeled incorrectly. I know they're on CXC. I hope that this one was labeled correctly. And here, you notice first we're going to solve for x. And you see this is an inequality. And then we're going to do some expanding, some simplifying. We have some algebraic fractions, and then we have some factorization right here. All right? Now, let's think about it. Let's start with A. So we want to solve for x, where x is a real number. 8 minus x is less than or equal to 5x plus 2. That's a plus. 5x plus 2. That's a minus. Now, when we're thinking about inequalities, they kind of work the same way like equations. So we can use the same ideas, but there's a catch. Remember, it's an inequality. So it only refers to a range of values. You won't just get one answer. Understand? So let's see if we can use that here. So we say 8 minus x is less than or equal to 5x plus 2. I want to solve for x. Just like in an equation, we solve for x by getting itself on one side in an inequality. So let's see if we can do that. So 8 minus x less than or equal to 5x plus 2. I can group like terms. I want to get x by itself at the end of the day, so we can group our like terms together. So that means I can carry 5x to the other side, or can carry 5x from the right to the left-hand side, and then I can carry 8 to this side. Right? So now, when we do that, makes it a little easier to work with, because we're basically going to be subtracting 5x from both sides. So that's going to be negative 5x minus x less than or equal to 2 minus 8. All right? Everybody clear with that? Oh, Robert, just think you're asking for me to go over. Where? Tell me where, so I can see if I can help. Where in it you're never so sure about. Another way that you can think about it too, because really what's happening is that, let me just write it here, less than or equal to 5x plus 2. What you're really doing, is that you want to get, as I say, you get x by itself on one side. So you can subtract 8 from this side, which means you'll also have to subtract 8 from this side. And you can, to get rid of 5x, you can subtract 5x from this side. Let me put it in white. But that means you're also going to have to subtract 5x from this side. So now 8 minus 8, that's gone. So that's going to be, that's why we get negative 5x minus x. And then when you have over here, 5x minus 5x, that's gone. So that's why we're left with 2 minus 8. All right? Everybody following me with that? So that's how we got to there. Couldn't you add x and subtract 2? Yes, you could also have done that. It would just mean that now x is on the other side. So it would just mean that the x terms are over here and the constant terms would be over here, right? So same thing. But I chose to do it this way because I wanted to make sure that I highlight something when you're working with inequalities, especially with negative numbers. Now, negative 5x minus x, that's negative 6x, right? And 2 minus 8 is negative 6. So, hold on. Now, we have, I just wanted to carry this up because I'm going to rub it out. Okay. Now we have negative on the left hand side and negative on the right hand side. So how are we going to get rid of negative 6? We can divide, right? So we can divide this side by negative 1. I'll put that in white. And you can divide the other side by negative 1. But now here's something very important to keep in mind when we're talking about inequalities. When you're dealing with inequalities, if you divide by a negative number, you have to turn around the sign. If you divide or multiply by a negative number, you have to turn around the sign. So what that means is that now my answer is going to be negative 6 divided by negative 1. That just leaves us with x. Turn around the sign, so greater than or equal to negative 6 divided by negative 1, which is 6. And so x would be, sorry, what? Negative 6. Okay. Yeah, x is greater than or equal to 1. That's the number I was looking for. Right? So x would be greater than or equal to 1. Remember, if you divide or multiply by a negative, then you turn around the inequality sign. Turn around the sign for the inequality. Why do we do that? Why do we turn the sign around? What is that, like magic? How we come up with that? Well, if you were to think about it, if we had solved it the other way, or if you were to multiply both sides of an inequality by negative 1, then the bigger side would be more negative. So you would have to adjust the sign to show that. So for example, let's say that I had 3 and 5. We know that 3 is less than 5, right? But if I multiplied both sides by negative 1, so if I times this by negative 1 and I times this by negative 1, then on this side of the equation, I'm going to have negative 3. And on this side, I'm going to have negative 5. Now think about it. Is negative 3 less than negative 5? Which one is greater? Is negative 3 less than negative 5? If you're looking on the number line, remember, less you're going to the leftmost. So you have negative 3 and negative 5. So actually, negative 3 is greater than negative 5. It's more. So that here would say negative 3 is greater than negative 5. So anytime you multiply or divide by a negative, you have to think about what happens in an inequality. And we have to just address that by just turning around the sign. So that's why we do that. Now, in the second part, we want to show our solution to AI on the number line below. So x is greater than or equal to 1. So we know we're going to be at 1. So we'll put our little circle here. Put it in yellow. And what is it? It's greater than or equal to. So because it's greater than or, specifically or equal to, we shade the circle, and greater than, so we know we'll be going in this direction. So on our number line, our solution would look like that. And so that would be our solution on the number line. Now we're almost heading to the end for today. But does anybody have anything that they're not clear on? Okay, Christina's asking, could you repeat why we changed the sign? We changed the sign because when you multiply or divide by a negative number, it basically switches around what happens. So if we had the numbers 3 and 5 here, 3 is less than 5. But if we multiplied both sides by a negative number, we get -3 and -5. And we know that -3 is greater than -5. So it's an observation that we make with numbers that we also apply to algebra. Because if this happens with numbers, then it's also going to happen with variables, which is why we say x would now be greater than or equal to 1. And does that help? So it's something that we observe and we say, okay, that's how inequalities behave. So we'll work with it. All right, great. So keep that in mind, because sometimes, especially when students are solving, they may miss out that part. Now, let us look at the B question, okay? So here, the B question, it says expand and simplify 2x times x plus 5 minus 3 times x minus 4. So let's work that one out. So we know now we're going to do some expansion. So that's going to be 2x times x and 2x times 5. Okay. So that's 2x times, oops, that looks so weird. 2x times x. 2x times x plus 2x times 5. Now, what about expanding the next one? Write in the chat for me what minus 3 times x minus 4 all in bracket would be. So let me see what you have for that one. So -3 times x minus 4. What's that? What is that? All right, I'm seeing an answer so far. Looking over on YouTube to see if I see any answers here too. So let's see what you guys got. All right, I'm seeing from, let me see who I see now. I see Sean, I see Christina, and I see Brittany. All right. I see Ninja too. All right. So the reason why I asked you guys to do that, because I want you guys to look out for the signs. Be very careful with the sign, you know, because it's -3 times x, and that's negative. So let me write it out. -3 times x, and then we're gonna have -3 times -4. So now we're going to have 2x times x, that's 2x squared, 2x times 5, that's 10x, minus 3 times x, that's -3x, and -3 times -4. Remember, a negative times a negative gives you a positive. So that is going to be plus 12. Right? So that is going to be plus 12. So be very careful of your sign. Be very, very careful of your signs. So now that's 2x squared. Let's first look, are there any like terms that we can simplify here? Here we have 10x and minus 3x. 10x minus 3x is what? 7x. Done? Yeah. So that's 2x squared plus 7x plus 12. And you get 2 marks for that. Specifically, we're looking for this. Teachers and the person's marking looking for that. But that's something that always gets students as well. So you get a mark for expanding correctly and then a mark for simplifying. Right? Now let's go down to C. It says 3x squared times, what was here? I think it was 4x to the 5th. Yeah, I think that was it. 3x squared times 4x to the 5th divided by 2x. Again, this was some simplification like what we did earlier. So since we did something like this earlier, I wonder if I can look in the chat again for you to tell me what it would be equal to. So I'll give you, let me put a time, a stopwatch on the screen. I'm going to give you 2 minutes. Can you tell me what that, oops, stopwatch too big. Can you tell me what that is going to be? Probably a minute and 15 seconds. What is that going to be when you work it down? Let me see what you get. So remember now, this is the little part of that's that part of algebra. We also include indices. So pretty important. So look out carefully when you're working with those. So let me see what you guys got. So let me see what you guys got. All right. So remember now, you want to write it, we're simplifying it enough. So I'm seeing some answers, but it's not completely simplified. So remember, we're simplifying it. It means we're writing it in the simplest way possible. One way we know if we simplify something is that we only have, especially when we're talking about bases and indices, we only have one variable by itself. So we don't have an x over here and an x over there. We just have the x at one part. Yeah? All right. So now let me look in YouTube as well. So I'm seeing some answers. So let's work it out together. Let's work it out together. If you got 6x squared, sorry, 6x to the 6th power, let's check that out. Because that would be it. So now let's look. So first, notice that we have 3 times 4. Because we know we can combine those like, I put those like terms close to each other as well. So we have 3 times 4, x squared times x to the 5th power, and all of that is over 2x. Now, 3 times 4 is 12. Boom. And you know, we don't even have to multiply them because 2 can go into 4 here. 2 into 2 is 1, 2 into 4 is 2. So that's 3 times 2, which is 6. And then we have x squared times x to the 5th. Whenever we're multiplying 2 terms with the same base, we can add their powers. So it's going to be x to the 2 plus 5. And then we're going to have that over x, right? 2 plus 5, that's 7. So that's 6x to the 7th over x. And then we know that we can cancel here, or we can subtract the powers because dividing. So it's going to be x into x is 1, x into x to the 7th is just going to be x to the 6th power. So that's why it's 6x to the 6th power. All right. So remember your, let me write that here, that would help you. Remember your laws of indices. Funny thing is, you could do it without the laws. You could write out all of the x terms. You could do that too if you want. You could do that too, but you know, it's a little longer. All right, guess what, guys? 10 more minutes. So let's see if we can do these last two. So we want to write as a single fraction in its lowest terms, x plus 1 over 2 plus 5 minus x over 5. So now remember, in algebraic fractions are just like regular fractions, okay? So in the same way, let's say I had like a half plus a third. How could we add those? How could we add those? Well, we know that we would find the LCM of 2 and 3, and the LCM of 2 and 3 is 6. Okay? And then we would say 2 into 6 is 3, 1 times 3 here, and then 1 times 3 is 3, 3 into 6 is 2, 1 times 2 is 2, and then we go forward. It's the same thing that we can do when we're doing algebraic fractions. Because it just remember it's numbers in it, so it just represents a regular fraction anyways. So first, see if we can find the LCM of 2 and 5. What's the LCM of 2 and 5? We know that's 10. Yeah, yeah. Somebody put that in the chat. So that's 10. And then we're going to say now 2 into 10. That's 5. So we're going to have 5 times x plus 1. And 5 times x is 5x. 5 times 1 is 5. Next, 5 into 10. What's that? That's 2. So now 5 minus x times 2. So we're going to have 2 times 5. That's 10. And 2 times negative x. That's negative 2x. All right? Now we see we have like terms. We have 5x and we have negative 2x. So 5x minus 2x, we can group those together. And we can also group together 5 and 10. And again, we're going to have all of that over 10. And now that's going to be 3x plus 15 all over 10. All right? So that's 3x plus 15 over 10. Let me ask you guys a question. Could I simplify it some more? Could I simplify it some more by saying 5 into 15 is 3, 5 into 10 is 2, so my answer is 3x plus 3 over 2? If you think that, if you'd say that we could do that, type a Y in the chat. If you say we can't do that, type a N in the chat. Do you think I could do that? Let me see what you think. I'm looking out for everybody now. You must have an opinion. You must think it's something. Either you're saying, yes, sir, that is it. Or no, sir, you're crazy. What side are you on? What are you thinking? What are you guys thinking? Let me see what I'm thinking here. All right, so some people are saying that they think we can do it. And then now I'm seeing somebody saying, no, sir, you all have to cancel. No, I'm going to pick that one out. We cannot do that. You can't do that. You can't do that. You can't do that. Because all as I'm seeing here in the chat, that's right. All of them would have to cancel out. You understand? So because this is a sum, anytime you're dealing with a sum, then it can't, you can't just pick something out of the sum and cancel. Either a sum or a difference. So like how we have 3x plus 15 over 10, you can't just pick out 15 to cancel. If you're going to divide 15 by 10, you'd also have to divide the 3x by 10. You understand? So because you can't do that, then we're just going to have to leave it as 3x plus 15 all over 10. All right? So again, that's a common mistake. So keep that in mind. if you're doing that for a sum or a difference, you would have to factor it out of everything. Follow me? Type a thumbs up if you get what I'm saying. Because here I'm just trying to tackle the main problems that I usually see. So give me a thumbs up. Do you get what I'm saying? Or give me a thumbs down or an N if you're saying no, you lie, and I said no. Let me see what you think. Everybody good? All right. Yeah. And I see some people retracting their comments on YouTube. Don't retract it, it's learn, we're learning, Learn, we're learning. You only can grow from if you learn something new and fix what you have. So if that's what you're thinking, you're learning, no problem. Don't take it away. All right, good. Let's go down to this part. Let's do this last one for today. 4x squared minus 4 is, well, we want to factorize. Sorry, I want to factorize that. All right. Now here, guess what? Off the bat, I noticed something. I wonder if you notice it too. You notice that both of them have a 4 in them? So they have a common factor of 4. So guess what I can do? I'm going to factor 4 out. So when I factor out 4 into 4x squared, that's just x squared. And 4 into negative 4, that would be minus 1. Right? So we're going to have 4 times x squared minus 1. But that's not when they mean what they mean when they say factorize completely. We still have a long way to go. Well, not a long way, but we still have some more stuff to do. So here, x squared minus 1. Does that look like anything you've seen before? Anything that have the word square somewhere in it? You ever see that before?
Difference of 2 squares.
Right, very good. Difference of 2 squares. So here, when we have x squared minus 1 written as the difference of 2 squares, what would it be then? What is this? So x squared minus 1. How do we write that as the difference of 2 squares? So let's kind of just jog our memory. Remember, for the difference of 2 squares, it's saying if you have 2 squares and you're finding their difference, it's the same thing as writing it as the product of their sum and their difference of the terms there, right? So here we have x squared. So notice if we have, let me write it under it. So we have x squared minus b squared. I know 1 squared is still 1. That means we're going to have, right, yes, Christina, that's going to be 4 times x minus 1 times x plus 1, okay? So that's the difference of 2 squares. If we have 2 squares and we're finding their difference, then we can rewrite it as the product of these two, right? And now remember, when you're writing it like that, don't forget, it's just gonna be x, not gonna be x squared. It's gonna be x, right? And that is how we factorized. And that's how we did 2 questions on CXC. So guys, here we are. This is the end, right on the dot, right at 6 o'clock. It's 1 hour. And yeah, we did a few stuff. So, you know, I'm happy that we got that done. So we're gonna stop here. As I said, each weekend I'm gonna be here working some papers leading up into the exam, some questions. Next week we're only doing this session on Saturday, right? So we're only doing the session on Saturday, so you can just sign in on Saturday. We're going to be doing linear programming. I hope this session helped you to get a little bit more familiar with some algebra. Looking in the chat, oh, it's 6 where you live. Mikhail, and 7 p.m. where you live, Brittany. All right, cool. Yeah, so you can sign in at that time then. I didn't really factor that part in. I didn't even factor that into consideration. You can get some more practice on our website, mymathcamp.com, specifically for those topics. Even leading up to that, you can get some practice with linear programming. You can check out the website to learn how you can get started, get signed up and stuff. And I'll see you guys next week at 5 for linear programming. Well, 6, 5 o'clock Jamaican time, 6 o'clock, 7 o'clock your time. All right, everybody. It's good seeing you guys. All the best. Have a great evening. Oh, by the way, for those who I saw one message for Saturday is kind of rough. Saturday is only for we're only doing Saturday next week, but after that, after next week, we're back to Saturday Sundays. So, and keep that in mind. All right, everybody. Take care. Have a great week and evening.